Hello, let's talk about stability. So here's our vessel. There's our boat. And what we have just here is, that's the center of gravity. So CG, we call that for short. And that center of gravity is forcing vertically down. So it's always first forcing vertically down. What we've also got underneath the vessel, we've got our center of buoyancy. So let's call that buoyancy. And buoyancy is always forcing vertically up. So in the center of buoyancy, no matter how the boat is heeling, it's always in the center of the underwater lying plane of the vessel. It's always forcing vertically up. So we've got two forces here acting on each other. We've got center of gravity always forcing down, and we've got the center of buoyancy always forcing vertically up. What we've also got on our vessel here, we have our keel. So that's just the bottom of the vessel there, that's called K. And up here, we have M. That's called the metacenter. And what happens is, that's where the vessel actually pivots when it's rolling. Pivots from M there, that point there. So this is a vessel that is straight upright. Let's talk about a vessel that's now heeling over. So this is the same boat, and it's just heeled over. There it is there. Here we go. That's M. That's K, the keel. Here's the center of gravity, we'll just call it G for now. But what's happened is, as the boat is heeled over, B actually stays underneath M, just there. So that's buoyancy right there. And it's still forcing vertically up. See how it's in the middle of the underwater plane of that vessel? Because there's the water line. So it's always forcing vertically up, and G's always forcing vertically down. So what happens if you just draw a straight line between M and B like that, straight down through the middle? What happens is, we create Z. So that's where G and Z meet, they're at the same height, and that's our GZ lever. So what's happening is, as we know, here's buoyancy, and it's forcing vertically up, which means it's almost like there's a lever there, and that's called the GZ lever. And what's happening is, the buoyancy is forcing up, G is forcing down, and it's acting like a lever to try and right the vessel back up. Now, you've probably heard when people say, if we lower the center of the gravity, the vessel becomes more stable. So this is what's happening in theory. So if we put G down even lower, so we've just moved G, let's just grab that bit out there. So we've just moved G now. So we move G down lower. So we've put the center of gravity of the vessel down lower on the boat, which means this line here is still B, the whole line is B, forcing vertically up. But what it means is, Z has now moved down because it's always at the same height, and Z's down here. And see how that GZ lever is actually bigger. So it's just like when you're using a stick with a fulcrum and you're trying to get some purchase. If you're trying to move a big log with a stick and you only have a short stick, it's very hard to move it. But if you have a super long stick, it's really easy to move that log, isn't it? Because you've got a little more leverage. Same can be said in this instance. Because the lower center of gravity is lower, we've created this bigger GZ lever, which is forcing the vessel back upright. Now that also means if we move G all the way up here, and which means Z moves up there, we've got this tiny little lever which makes our vessel super unstable. So if we've got it there, so as long as G is under M, the vessel will always try and upright itself. But if we put G above M, so the center of gravity is actually above the metacenter, that boat will just basically tip over and topple because it will pivot around that M point. That's very much the basics of what's going on. The end.